Okay, so I'm just going to work numbers 4 and 6 here to give you guys a good idea of what a related rates problem could look like. I'm choosing the two that are the most common. Number 4 is going to have to do with a cone. Okay, so we've got a paper cup, which is in the shape of a right circular cone, and I always ask my class to sketch the picture first and label as much as possible. So here's our cone. 16 centimeters deep, so I'll label that as a 16. So height and depth are kind of the same. It has a radius of 4, and water's being poured into the cup at a constant rate of 2 centimeters cubed per second. Now, when you see the word rate, you don't label it on the picture. You could just kind of label it out to the side. So we are filling up the cup and changing the volume, and that's another indicator that this is a change in volume. So we're going to label that dV dt, the change of volume with respect to time, and that's equal to a positive 2 because we're filling the cup up. Okay, so let's look at what it's actually asking for. Part A is going to ask when the depth is 5, and I'm going to call that h. When the height is 5, what is the rate of change of the height? So what is the dH dt? And then part B wants us to then find when the radius is 3, what is the rate of change of the radius? So this is what my brain read out of that problem. And now I'm just going to try to solve it, okay? So what do I do first? Well, after I've labeled what I can, okay, and I know what I'm supposed to be finding, the next step is to find a good equation to relate all this stuff together. Well, volume is going to be the ideal equation, and that's 1/3 pi r squared h for a cone. And this is needed because, well, you have a dv dt and then h is in r, so this is a great equation. Now you're supposed to plug in anything that is constant at this point in the game. Nothing is constant though. If you guys can visualize water being poured in, as this is filling up at different levels, it's going to have a different radius and a different height as the water's coming in. So don't plug anything in early. Now, you might be tempted to take a derivative right now. Don't do that yet. You need to look at what the goal is. Now, for part A, everything has to do with the letter h. The h is 5, the dH dt. And what that should tell you is h is good. H is very good. Keep it in the equation. R is bad. So before you take a derivative, get rid of R. Get rid of the variable that you don't want. And to get rid of R, all that means is figure out a relationship between R and H. Okay, so if you look at your picture, when R is 4, H is 16. So I just did a little proportion with my picture, okay? When the radius is 4, the height is 16, and I'm going to cross multiply. 16r is 4h. Get rid of the 16 in front of the r, so I'm getting r equals h over 4. So this is just doing a proportion, rearranging it, and what I'm going to do is I'm going to replace this r in my equation, so I'm going to substitute it with h over 4. And this is going to be really good now, because now when I take a derivative, I will have dv dt and dH dt, and those are the two things that this question is asking in part A. Now before I take a derivative, I'm going to clean this up. I can't take a derivative like that, it looks really ugly. So let me square this and multiply by h. So that would be h cubed over 16. And then we have here, the pi would go on top, and the 3 is on bottom. Okay, let me go ahead and do 3 times 16. I think that's a 48. Okay, so this is just me cleaning things up because my next step is taking a derivative, and it's much easier to take a derivative once you've simplified here. So to take a derivative, the derivative of v is 1 dv dt. The derivative of this side, okay, don't get confused by this, it's just a coefficient. So I'm just going to take the derivative of the variable. So h cubed, the derivative would be 3h squared, but I still have this pi over 48. And then dH dt, I just took a derivative of h with respect to t. So this is my derivative, and now I can plug in what I know and I can solve for what I don't know. Above, it told us that this was 2. It also told us that the h was 5. Okay, so 5 squared is what? 25 right here. And then times 3 is 75. Okay, so that's just me putting numbers together. 5 squared is 25. 25 times 3 is 75. It'll go in the numerator, and I recopy the denominator. Now, I'm solving for dH dt, so I'm just going to multiply both sides by the reciprocal of this. And that's going to be my answer, folks. I will need a unit on it, okay? And I also want to clean this up. Does that reduce at all? I think it reduces by 3. That would be a 16 over 25. Okay, so I am getting 32 over 25 pi. And this is going to be something per something. It's a rate. So in the problem, I don't even know. I think it was centimeters and seconds. So we're going to have to put centimeters per second on our answer. All right, cool. So that's part A. Now for part B, I'm going to go faster because it's the same stinking thing, except now everything's in terms of R on part B. And so what that means is that what you're going to want to do is right here when we had the proportion and we were like, oh, let's get rid of R. Well, now you want to keep the R because that's what everything pertains to. So you want to get rid of H. So to get rid of H, you still cross multiply. 16R equals 4H. But now let's isolate H instead. So I'm getting that H is equal to 4R. And so what that means is in this step, I'm going to come back here and erase all this jazz. Because now when I go to plug in, it'll be 1/3 pi, and then it'll be R squared, and then H is now 4R. And same thing I did before. I'm going to take a derivative in a second, but let me clean this up first. This looks like it's going to be 4 pi over 3 R to the third, and now I'll take a derivative. dv dt equals 4 pi over 3 times 3r squared dr dt, and now we can plug in whatever it told us. This was still a 2. That 3 and that 3 are going to cancel, so I'm going to have 4 pi. What did it say for r? I think it's when r was a 3. So this is now, bless me, that's now 9 times 4 is 36, so it's a 36 pi dr dt, and I'm going to divide both sides by 36 pi. So I'm getting 1 over 18 pi is equal to dr dt. This is a rate, so it's still centimeters per second. All right, cool. So there's your number 4. Now I'm going to skip to number 6. It should go a little bit quicker, just because that number 6, the volumes are always the toughest, especially volume of a cone. They are pretty terrible for most people, but if you can do a problem like that, you can pretty much do anything. Okay, let's go back up and erase la. Okay, so now we're on 6, which is the one that you see right here. Okay, so we've got a balloon rising, and it's rising at a constant speed of 5 feet per second. So here's my balloon going up. Yay. Okay. A boy is cycling along a straight road, so he's going to be under the balloon. And I'm going to have him cycling this way. It doesn't matter which way, but I'm going to make him go this way. And he's 15 feet per second. Okay, so I've got 2 rates right now. Now, just by the setup alone and the fact that I see a right angle, I know this is going to be a right triangle, which is a very famous type of problem. And I need to decide what to call the these 2 sides of my triangle. So you can do A, B, C. You can do X, Y, Z. I'm going to go ahead and call these A and B. Okay? So I know from reading this that the balloon, the dA dt, the rate that it's changing, is a 5. And it's a positive 5 because distance is increasing. And the boy is traveling, his dB dt, his speed is 15 feet per second. Okay, now when he passes under the balloon, it is 45 feet above him. So when he's here, this is 45. How fast is the distance between the boy and the balloon changing? So it doesn't want the distance between them, it wants the rate the distance is changing. So this is what I'm supposed to be finding. Here's my question mark. 3 seconds later. So we're supposed to find this 3 seconds after he passes here. So what you're going to need to do is actually find the lengths of these triangles before you even start the problem, because it's 45 right now, but 3 seconds later you have to think, well, how much more did it rise? Well, if it's rising at 5 feet per second and we go 3 seconds later, then you need to add 15 to what you saw here and get 60. Same thing down here. If it's 3 seconds later and he's going 15 feet per second, then how far has he gone? Well, 3 times 15 is 45. So we know this length is 60, we know this one's 45, and we can do Pythagorean theorem before we do anything else to find that c squared. I think it's just easy and smart to label everything you can before you do actual derivatives. So we're going to get a calculator because I don't want to do that. Okay, 60 times 60 is, I should have known that. Okay, plus 45 times 45. Oh man, it's not going to let me do that. 45 times 45 equals that, plus 3,600. Okay, so I'm getting 5625. I wonder if that has a square root. Oh my gosh, it does. It's a beautiful day. Okay, 75 is what my calculator gave me. So now we know the lengths of the sides, and now we're ready to do some derivative stuff. So let's take an equation that relates everything together, and it's the same one we already used, hint, hint. So this is the formula I'm going to use. Now I'm not going to plug anybody in yet because this is changing as time goes by. This is changing as time goes by. And this is changing as time goes by. So I'm just going to leave this alone and go ahead and take the derivative. Don't forget all your notation as you're taking derivatives here. And now start plugging stuff in. Okay, so for me, A was this leg. So it's going to be 2 times 60 times the rate of 5. Plus 2 times 45 times the rate of 15 equals 2 times 75, which is what we just found, times the rate, which we don't know, and that's okay. We needed something to find, right? So this is what we're going to be isolating. So it's going to be from here just a gross calculator problem. Okay, so it's going to be 120 times 5. I'm getting 600 here. Plus, that's going to be like 90 times 15, 1350, and then that's equal to 150 dc dt. So I'm not talking much except to myself here, guys, because this is just mathing it out at this point. That's a 1950, so we need to see what 1950 divided by, maybe it's pretty, you never know. Where's the division? There we go. Divided by 150. And it is a pretty number. 13 equals dc dt. So it's a rate, and I can't remember the units from above, but I want to say it was like feet per second. So that's what we're going to do. Okay, cool. So that's our answer. Hopefully that made sense, and these are great problems because you're probably most likely going to see at least one of each of these. So good luck to you.